So this is a classified paper. It's about 99 pages file with the answer key. After every question, you will find the answer. So figure 7.1 shows an object and its image formed by a converging lens. One ray from tip of the object to the tip of image is shown, as you can see here, and this is drawn to full scale, so you can do measurements as well. Now the question is, so what we have to do? We have to place a tick all the boxes that correctly describe the image. You can annotate on the screen. Place the tick. It is inverted. That is one. And real images are always inverted. So as you come, if you compare the size of object with size of image, the image is smaller, so it is diminished, and it is inverted, and it is real. The next part is on figure 7.1, draw rays passing through the principal focus from tip of object and determine the focal length. So what we have to do? Yeah, we have to draw the ray to find out the focus. How we can work out the focus? You can annotate on the screen if anyone want to. How we can work out the focus? If you want to work out the focus, so what we should do? So we'll draw a line parallel to the principal axis. Yeah. So you can start with image, you can start with object, as they already mentioned. So if you draw parallel, and it will, and it reach the image, so this will be the focus. So this point will be the focus. Or if you want to continue from the image, you can do that as well. Like if it was parallel, then it reaches the tip, so that will also be the focus. Any one of them you can draw. Then we have to measure this length. What is the focal length distance from the center of the lens to the point where the parallel light ray converge? That is known as the focus. So you have to measure this length, but because we are not, this is not like we cannot measure on this scale. That's why we'll skip this part. The next is draw another ray which is not passing through the principal focus of the lens and from tip of object to the tip of image. So we have to draw another ray. Where I should draw another ray? Like this one example is already drawn. The first one they showed, and this one we drew to work out the focus. Where I should draw another ray which should not pass through the focus. Any other point should not pass through the focus. Yeah, that's right. So what we can do, we can draw anywhere, not parallel, but from tip of object anywhere and reaches a tip of image. And that is not passing through focus. If you draw this one, like if you draw through the lens and then this is not correct. Why it's not correct? Because this will pass through focus. Because parallel pass through focus or through focus will go parallel. So you're not supposed to draw this ray. You're supposed to draw another ray. Anywhere you can draw, just from tip of object to reach the tip of image. But it should not pass through the focus. Figure 6.1 represent, this is page number 2. So figure 6.1 represent the electromagnetic spectrum. State the radiation in each region represented by A, B, C, and D in figure. So What is A? So radio, micro, and that is infra. What is B? Ultraviolet, X-rays, and gamma. So this one is infra, you can say IR. This one is ultraviolet, you can say UV. This one is X-ray, and the last one is a gamma rays. Okay, so here we'll have X-rays, and here we'll have the gamma. A source emits visible light. Figure 6.1 shows a ray. This is page number 3. So a source emits a visible light, as you can see. Figure 6.2 shows a ray of a red light from the source and incident on face XY of a glass prism. The angle of the incidence is 35. The refractive index is 1.5. We have to calculate the angle of refraction. So how we can work out the angle of refraction? Because it's traveling from air to glass. So as it travels from air to glass, what is the formula for refractive index? Yeah. So refractive index will be equals to sine I over sine R. What is sine I? You can also annotate on the screen. Anywhere on the screen you can annotate. It's not an issue. Or you can also use chat or a mic. So the angle of the incidence is 35 and the refractive index is 1.5. So we want to solve. Here I'll solve. So we have 1.5 sine 35 divided by sine R. We cross multiply. So sine R is equals to sine 35 divided by 1.5. Keep one thing in mind, the theta should always be in degrees when you are using this. So how to know, how to check your mod of a calculator in degree? So sine 90 is always 1. So if you put sine 90, if you get one answer as 1, it means your mod is in degrees. So sine 35, what's the value for sine 35? Sine 35. Sine 35 is 0.57 and divided by 1.5. Is it 57 or 37? 57, okay. So 0.57 divided by 1.5. 0.57 divided by 1.5. So it will be 0.38. But what we need R. So sine will move other side. So if we need R, it will be equals to sine inverse 0.38. So what is R? So the angle of refraction is 22.33. What is the next number after that? 38. 33. Maybe the values. Okay. So we'll take as 22 or 20. So this is the angle of the refraction, 22.33. Okay. So 22.33, or you can say 22 if you round off. So this gives us the angle of the refraction. The next is, on a figure, draw a refracted ray at face X and Y, and that emerges, and label this as R. So we have to draw a refracted ray, but see, angle of refraction we already worked out. What was that? It was about 22. So what you have to do, you have to place a protector, mark 22, and draw the refracted ray. And then it emerge out, because moving from air to from glass to air, it will bend away from the normal. This angle, because we did not measure, so you can draw any, but the first one should be measured one, and this will be the refracted. emergent one, and we label that as R for dimension. This angle must be 22 or 22.3. 0.3 will be very difficult to make, so it's 22 is fine, rounded off value. Then we have a ray of a blue light follows the same path, so we have to label that as B. So if this was a red, how the blue light, it will bend more or less? So blue is having a high frequency than red. So the one which is having a high frequency will have a greater change speed, so it will bend more. So if I want to sketch the path for a blue light, so blue will bend more and greater refraction. So, and that we label as B. So higher frequency of a light means greater refraction or greater bending or greater change in the speed. So this was page 3. Next is page 4. The speed of a light So speed of a light in air is 3 exponent 8 and the refractive index is 1.33. We need the speed in a medium. What's the formula to work out the refractive index and speeds? So the formula is actually the speed of a light in air divided by speed of a light in a medium. So refractive index is 1.33. The speed of a light is 3 exponent 8 and speed in a medium we don't know. Cross multiply. So speed will be equals to 3 exponent 8 divided by 1.33. So 3 exponent 8 divided by 1.33, what we get? It should be an exponent. Just do 3 divided by 1.33. Just divide this 3 with 1.33. Leave exponents, just do 3 divided by 1.33. 2.25, 2.26. Okay. So 10 raised to power 8 will be there, meter per second. That's the speed. The next is on a figure, draw figure 7.1 shows a parallel wavefront of a light incident in a boundary with the plastic. We have to draw the position of 4 refracted wavefront, direction in which the refracted travel, and angle of a refraction. So how we can do this? First, when a light travel from air to plastic, what happened to speed of light? Increase or decrease? For a light, for a sound, when it travel a denser medium, it travel faster. But for a light, it travel slower. So it will decrease. So as the speed of a light will decrease, so if this is a wavefront in if it was traveling at the same speed, then that's how we should draw. But because it is traveling slower, so it should lag behind. So as the speed of a light has decreased, so it lag behind. This is how we should draw. If the speed was increasing, then we will draw another way, like we will extend. Now to show the direction of the refraction, the direction of the wave front is always perpendicular. So if this is a wavefront, so what is the direction of refraction? Always 90 degrees. So when you draw a wavefront, draw perpendicular line to the wavefront that shows the direction of the wave, which direction it is traveling. And then we have to measure the angle of the refraction. So you will draw a normal here. You will draw a normal using a scale, draw the normal and label that as R. So this will be the angle of refraction. If they say draw an angle of label angle of incidence, so how will draw angle of incidence? If this is a wavefront, so this will be the direction of the wave, and if this is the direction of the wave, so this will be the angle of incidence. So because it lagged behind, so the angle of the refraction should be smaller than the angle of incidence. If it was a sound wave, then opposite will happen. In air, it travels slower, but in a transparent block, it will travel faster. The direction, this direction The wavefront which we drew, this one and these two should be 90. And this is a wavefront which is already given, and the direction which you drew, that should be 90. 90 to the direction of the wavefront which we drew.